All right, let's jump right in. Have you ever stopped to ask yourself a really basic question? How do we know what we know? It sounds simple, but the way we've tried to answer that has completely reinvented our world over and over again.
I mean, this is the fundamental question that's driven human curiosity for, well, forever. But here's the kicker. What's really changed over time isn't just what we discover, but the very process of how we discover it.
You know, we tend to think of science as just a big collection of facts, but it's really a method. It's a systematic way of asking questions, and that method has a fascinating history, a story full of revolutions and reinventions.
So that's what we're going to do. Let's take a journey through the major paradigm shifts in scientific discovery from ancient intuition and controlled experiments all the way up to modern artificial intelligence.
Okay, first up, the first great leap. This is where we went from just passively watching the world to actively testing it. And this was an absolute game changer. Just look at the incredible contrast here. You had the empirical stage, think ancient astronomy or Ayurveda, which relied on passive observation and tradition. But then came the experimental stage, pioneered by folks like Galileo, and suddenly that wasn't enough. It demanded active, controlled tests. Truth was no longer just what you saw, it was what you could prove again and again. But of course, neither method was perfect. Pure observation could be seriously misleading. I mean, for centuries, people watched the sun move across the sky and concluded the Earth was the center of the universe. It makes sense, but it's wrong. And on the flip side, experiments brought their own set of challenges. They could be expensive, and sometimes the lab conditions were so artificial, they didn't really tell you much about the real world.
So to get past these limits, to understand things we couldn't directly see or test, like gravity or the cosmos, science had to evolve again. It needed to get abstract, moving beyond the purely physical world and into the world of ideas.
And this is the era that brought us the heavy hitters. We're talking about paradigm-shifting ideas like Newton's laws and Einstein's theory of relativity. These weren't just observations. They were these elegant mathematical frameworks that could describe the very fabric of the universe and even predict its behavior.
But there was a catch. These beautiful, elegant theories often had to simplify reality just to be solvable by a person with a pen and paper. The real world, in all its messy, chaotic complexity, was often just too much for the math to handle.
The solution was to bring in a powerful new tool, the computer, and this kicked off the computational stage. Now scientists could build a theoretical model, translate it into code, and run incredibly complex simulations at high speeds to see how well their big ideas actually matched up with reality.
However, this introduced a totally new danger, what we call the black box problem. We might trust the output of some hugely complex simulation, but if there's one tiny error in the code, or one flawed assumption buried deep inside, the results could be completely wrong, and we might not even realize it. And that brings us right up to today, to our current era, and a whole new way of doing science. This one is driven not by human-led theory, but by an overwhelming flood of pure data. To give you a sense of scale, 40 petabytes a year, that's roughly the amount of data generated by the Large Hadron Collider at CERN. It is a data deluge so massive that no human being could ever hope to sift through it all manually. This absolute explosion of information led some to make a really provocative claim back in 2008. The thinking was, with so much data, maybe we don't even need theories anymore. We can just let the algorithms find the patterns for us. So, is it true? Have we reached the end of theory? Is the hypothesis dead? The argument is that with enough data and a powerful enough AI, we can discover correlations and find insights without needing to guess first. But, as it turns out, it's not quite that simple.
Yeah, this new data-driven paradigm is absolutely filled with pitfalls. If your input data is flawed, your results will be flawed. Period. AI can also amplify human biases hidden in that data. And it's great at finding patterns that are just random chance, these spurious correlations, or even hallucinating results that have no basis in reality.
And all of this brings us right back to the most critical and the most constant component in this entire story, the human scientist.
With all these powerful new tools at our disposal, experiments, theories, simulations, AI, we face a really stark new reality. The potential for error, for being misled by our own incredible creations, is now greater than it's ever been before.
So this forces us to step back and ask a deeper question. Beyond just discovering things and building models, what is all of this for? Why do we even do it? And ultimately, the answer is a powerful reminder that the goal isn't just knowledge for its own sake.
The real value of science lies in its application, how it can be used to serve humanity and to make society and the planet better.
So that leaves us with one final fascinating question. We've journeyed from observation to experimentation to theory and now to data. What comes next? As we enter this age of powerful new AI, the fifth paradigm of discovery is waiting to be defined. And the only question is, what will it be?